Adding vectors graphically. In this section, we're going to learn how to add vectors graphically, and there are two rules that we follow. Number one, vectors are placed head to tail. And note, when you do this, you have to follow the rules for moving vectors, which means the length of the arrow cannot change and its direction cannot change. Two, draw the resultant or the sum of the vectors from the tail of the first to the head of the last vector. Quick little simple example to start with. Add these two vectors graphically, a vertical and horizontal vector. Gives us this situation right here. Head to tail, draw the resultant or the sum from the tail of the first to the head of the last, or adding them in a different order, red and then blue, gives us the resultant R. But notice, R is the same in each case. So, you can add the vectors in any order, and the resultant will be the same. The same as adding 1 plus 2 or 2 plus 1. Second example. Add these vectors graphically. And in this case, we have 3 vectors, which gives us this resultant first, black, blue, and red, with green being our resultant. Or we end up with this situation where you have blue, black, and red. Again, vectors are added in a different order, resultant from the tail of the first to the head of the last. Notice that this resultant is the same as that resultant. And again, we see adding the vectors in a different order produces the same resultant. Our last method is called the parallelogram method. Now this one's going to be a little different in that we do not place our vectors head to tail when we add them initially. In this particular case, a parallelogram is constructed to find the resultant. Here's a quick example. Add these two vectors by constructing a parallelogram. Red and blue vectors. We construct a parallelogram by constructing a vector parallel to this blue one and a red vector parallel to the initial one. And draw the resultant from the tail of the first to the head of the last. Now notice, even though we did not place the initial vectors head to tail, when we drew the parallelogram vectors, everything became head to tail. So when we connect the tail of the first to the head of the last one, we get the resultant R.